Okay, well, let's find some domains. We've got a radical here, and here we have a fraction. So let's do the radical one first. When we say find the domain, we're saying what x values are possible in this expression. So really the thing we have to worry about with a radical is whether or not this radicand here is negative. We cannot have this be negative. So what that means with math symbols is that we need this to be bigger than 0 or equal to 0. And that will make it non-negative, right? So we can do that. We're just going to take the radicand, negative 6x plus 5, and we need it to be bigger than or equal to 0. And now we just have a nice inequality that we can solve pretty quickly, right? We're going to take 5 away from both sides. Greater or equal to negative 5. We're going to divide by negative 6. So here's where we're going to make an error. Be careful when you divide or multiply by a negative number with an inequality. You got to switch the sign around. Okay, so we got negative 5 divided by negative 6. So the negatives are going to cancel out. We got 5 over 6. So our domain in the first case is that we need x to be less or equal to 5/6. I mean, we could write this in a couple of different ways. We could make a nice little set builder notation, or if we wanted to write it in interval notation, which looks like what the computer wants. We will write it in interval notation, so we want x less or equal to 5/6. So 5/6 is the biggest thing in our interval, less or equal, so we're going to include it. And then the smallest thing is negative infinity, and we're done. Okay, so there's our domain in the first case. And again, with radicals, we do need I should be more specific. With even indexed radicals, we need the radicand to be larger or equal to 0. If this were an odd number up here, like if we were doing a cube root or a fifth root, then we can have any real number underneath there. Well, provided it's a polynomial, I guess, but I think I'm getting off the point. Usually we're just going to encounter square roots, which don't have a little number in here, and we do need this to be non-negative or greater than or equal to 0. All right, so let's look at this one. We've got a rational here. So when we have fractions, the big no-no with fractions is that we can't divide by 0. So with this, we need we'll just do it just like the other one, right? So we need this not to be 0. So the process for this one, we can just take, the denominator and set it equal to 0 and find out what value that would be. And this one's pretty quick. We saw that really quickly. So if we find here that if x is equal to negative 1, then that denominator is not going to be 0. So we need this to not be the case. So we can write it in set builder notation if we want a set of all x values such that x is not negative 1, or we could write it in interval notation, which again the computer wants from you. So we want everything except for negative 1. So we're going to go from negative infinity all the way up to negative 1. We're not going to include it. And we're also going to have another interval that we're going to union this with, so everything to the right of negative 1. So negative 1, comma, infinity. So we've got our domains